LAN or local area networks. Now LAN or local area network, this is a private network, and this can be operated in a room, in a building, in an office or home. So we are talking about a higher network than personal area network. So LANs, these are widely used because we are connecting various PCs and to share resources, exchange information. So the LANs can be wired, it can be wireless. It can be wired and wireless. So there are two examples I am showing here. One is the wireless, one is the wired LAN. So the wireless LAN system, here the computer will have a radio modem. Modem is basically modulator, demodulator, analog to digital, digital to analog, and also an antenna, because to communicate with other computers. And here each device talks to a device. Every device, that is the computing device, for example computer, is going to talk to access points, to wireless router and to the base station. Now if you see here, there are two ways. One is the wired, the left one is wireless, the right one is wired. The left one is wireless, there is no wire in between. So a LAN can be wired, it can be non-wired. So now this system one, or a computing device or a computer, now this wants, it will not always be a computer, it can be any computing device. Now there will be a central say exchange point, and we call it as a switch. Basically it's a network device. So this is a Ethernet switch, and now this connection is like this. You go through a switch and then you connect. That is, both of the computer or the computing device will be connected to the jack of the switch, and this is how the communication will take place. So this is a switched Ethernet. What kind of Ethernet? It's because we are using a switch. Okay. Now here, this in the wireless, we have an access point. These are the different computing devices, and they are accessing it through an access point. So wireless router, access point, base station we are talking about when we are talking in terms of wireless LAN. Now the device is relaying the packet or sending the packet between the wireless computers, in between them, and also to the outer internet. Okay. There is also a mesh network configuration where the devices, the computing devices, can also send and receive packets from one another. Why I am saying that? Because in these both cases, the devices has to send it to the switch and then it should come back. That is, there is no direct connection between two devices. It has to go through switch. It has to go through access point. But in mesh network, it is possible. As I am saying, relays may be the same nodes as the endpoints. Same nodes means computing devices. Endpoints where the communication stops. Or a separate collection of nodes whose sole responsibility is relaying traffic. So the switch and access points, they have only one responsibility, to relay traffic. Now Wi-Fi is also coming in LAN. So it is a popular standard of wireless LAN. What is the IEEE number? It is 802.11. IEEE is making the protocols, it is defining the standard. So let me tell you the brief idea about this Wi-Fi. So it all started way back, but the prominent ones are 802.11a, started 54 Mbps. These are the different frequencies, mostly the frequencies which are free of the ISM band. And then we have 802.11b, 802.11g, then N, then AC, AX. You will also read somewhere AD. So all these are different flavors, different types with different speeds and working on different frequencies. Mostly if you see from 2009, it was between 2.4 gigahertz to 5 gigahertz, and the speed has gone up to 10 to 12 Gbps. Now when we are talking about wired LANs, the transmission technologies can be different because the wire can be different. You are sending the data or the bits or the packets from one device to another. So you can use the copper, coaxial cable or optical fiber. See, the LAN has a limited size. It can only be up till a building or a home or a house. So the size are limited. When you know the boundary, you know that what will be the worst case transmission time. It is clear. If we don't know the size of the LAN, or we'll know it later also, that if in advance we don't know, then we are not able to comprehend the worst case transmission time and performance and etc. The weakest link will be there. So this we'll talk later. But now the wired LANs will always give you more speed. This is very important. Wireless will always have less speed than the wired LAN, because it's very obvious that there is wire connected, proper transmission channel is there. When there is air in between, there are so many attenuations, so many situations arises. Okay, the wired LAN will have low latency. Latency means the time it starts and reaches the destination. There will be the errors will be very less in the wired LANs. The throughput will be higher. Throughput means you can say at a point how much bits can travel, means or how many content can travel. So we'll talk about this throughput and latency and all these in detail. But for example, for time being, the latency, the errors and the throughput, all will be, latency will be less and the errors will be less, throughput will be higher. In the wired LANs, you won't get it in the wireless LANs. Now what I'm showing right now is the IEEE 802.3, and that is called the Ethernet. We also talked about earlier who is the inventor of Ethernet. Okay, I want you to tell me. So this is called Ethernet, and this is the most common type of wired LAN. Ethernet 802.3 is the most common type of wired LAN. Okay, so I'm talking about this kind of arrangement. So this figure is showing an example of switched Ethernet topology. Here we are using a switch. So a computing device or a computer or a laptop will have a Ethernet port, and that is how we connect through this wire, Ethernet wire. So before we go ahead, let me tell you what is this switch, how does it look. This is how it looks normally. So the work of this network switch, which is actually connecting different devices or relaying the data. Now this network switch is a hardware device. We will talk about routers, we will talk about gateways. But right now, for the basic of LAN, there will be a Ethernet switch, and a network switch is networking hardware that connects devices on a computer network by using packet switching to receive and forward data to the destination devices. That is a network switch. As you see there, it is multi-port network bridge that will use the MAC, that is the address to forward data to the DLL, data link layer of the OSI layer. Okay, so we are talking about a switch. Whenever you see 802.3, that is, we are talking about a switch. So each switch is responsible for sending the data, knowing the address and sending it to the proper address. Okay, so each device speaks Ethernet protocol here, and it connects to a device which I'm showing you switch with a point-to-point link. So as I'm suggesting, this switch is relaying the packet. Packet is just a combination of bit. Okay, it has a proper format, and it sends the packet, relays the packet to the computer or computing device attached to it. And in this packet, the address will be there. So the task of switch is to determine that the address of the packet is destined where to send. So the switch can have multiple ports. So if you see here, there are multiple ports, and you can connect it to the computer, and you can even compute it to another switch. In order to make a larger LAN, you can have multiple switch connected to each other, because these ports can be used to connect the computing device and even to connect the other switches. Now the question arises, what if we connect these switches in a loop? Are this network going to work? Because switch will just take the packet, send it to the destination. This is how it is done. Now we have a switch. Now we are looping it. Now where the data should go? There will be some looping of packets. But we have a solution. Very important women will be talking about her. If you know the name, just let me know. All switches now have this anti-looping algorithm. I'm giving you a hint, STP. So we are using this anti-looping algorithm here. So there will be, even if you put it or attach it in the loop, there will be no problem. So the protocol means all the rules and regulations that have been decided what path packet should travel to reach the actual destination, that is the intended computer. So it is possible to divide one large physical LANs into two smaller logical LANs. There are two things I want to highlight here. One is the looped traffic. See, this is looping, okay? Going back, coming again. So there will be a situation here and we solve it using anti-looping algorithm. And there is one problem of flooding of traffic also. That also, there are solutions for that. But these are the general problems or challenges we face here. Now, a LAN, as I said or suggested, it can be divided into number of logical LANs. We are not physically dividing it. We are just logically dividing it. Where are the situations that arise? I'll give an example. For example, there is an institution. We have engineering department and finance department of a company. Now, we would like all these are connected to a single LAN. But a single LAN won't work. We want this engineering department to be different and finance department to be different. So we can have a virtual LAN, VLAN. How will we design this? In order to do this, each port is, as I told you about the switch, so each port is tagged with a color. And now we are giving certain color to certain department. For example, we are saying that we give green for engineering and red for finance. You can choose any color. But this is the basic idea you should know. The LAN can be divided into multiple logical LANs. So the red is for finance and green is for engineering. Now switch will forward the packet accordingly. If it is destined, it is for engineering, it will go, depending upon the color, it will go to engineering only. If it is for the finance department, it will go to finance department only. So broadcast packet sent on a red port will not be received on a green port and likewise. So this local area network, here Ethernet design broadcast all packets over a single linear cable. This is what is the design. Ethernet will always try to broadcast all packets, right? Now, this switched Ethernet, that is we are calling it as a classic Ethernet. Whenever we are talking about Ethernet, we are calling it as a switched Ethernet or classic Ethernet. Now it uses a very simple algorithm. The algorithm is, whenever the cable is not having any packet, the computer will transmit or the computing device will transmit. That is, whenever the cable is idle, because as I said, the normal routine is Ethernet design broadcast all packet. But this algorithm says that computer or computing device will only transmit when the cable is idle. If two or more packets, they are colliding, they will collide for sure. Okay. Now what will happen is, each computing device now have to wait. They will wait and they will try later. We will talk about CSMA, we will talk about CSMA CD. But this is just an introduction I am giving you, that we have the algorithm. This is the flowchart also I wanted to show, that both wired and wireless broadcast LANs, they can allocate different resources. It can be statically, it can be dynamically. Static dynamic, what does it mean? See, a typical static location or allocation, if you are talking about static allocation, because everyone has to send data, this is all about exchanging data. So what this static allocation will do, it will divide the time into discrete time intervals. So it will say M1 should do in this time, M2 should do in this time in round robin, M3 in this time. These are the machines in the round robin algorithm. Okay, every machine will get a stipulated time, and after that M2 will send, after this M3 will send, M4, M5. And then if say M5, 5 machines are there, again then the M1 will send. But the problem is, when the M2 times come, M2 doesn't want to send. It has nothing to send. For example, 1 millisecond is provided to every 5 machines. It is going round robin. Every time when it comes to M2, M2 is not ready to send. It doesn't want to send. Say M3 is also not sending. So the time that will be wasted, the static allocation wasted the channel capacity. Okay. So now we have the dynamic allocation method for a common channel. This can also be centralized. It can be decentralized also. What does it mean? Centralized means there has to be someone to guide. Decentralized means no one is there. Let me tell you again, both wired and wireless, they can allocate the resources statically, dynamically. Static is simple round robin. Everyone is given time and their time is theirs. but it wastes the channel capacity. But the dynamic, there will be centralized, decentralized. Centralized, there will be a base station. So for example, in a cellular network, we have base station. It will decide who is going to go next. Okay. There will be some internal algorithm to decide who will be prioritizing. If this M2 should send first or M3 should send first. This is the algorithm they are going to use. This is the centralized way. And in decentralized, every machine has to decide by itself when to send, when to transmit, when not to transmit.